A work solution to page 256, number 12, from Introductory Analysis by Dolciani et al. The base of a right triangle is increasing at the rate of 5 centimeters per minute, and its height is decreasing at 4 centimeters per minute. At the moment when the base is 3 centimeters and the height is 4 centimeters, A, is the area increasing or decreasing, and how fast? B, is the hypotenuse increasing or decreasing, and how fast? So our first thing, as always, is to draw a picture. So we decide to draw our triangle, which has a height and a width, of course, and is a right triangle. And we give names to everybody, so let's call this L and X and Y. Then we go back to the problem. We say, what do we know about these things? Well, we know that we're given that dx dt is 5 and dy dt is minus 4 because it's decreasing. And then the moment that we have, the time that we have, is such that we want to know when x equals 3 and y equals 4. We want to know what is dA dt, where A is the area, and what is dL dt, which is the length of the hypotenuse. We'll get each of those separately on their own page. First, the area. The area of a right triangle is, of course, 1/2 the base times the height. Since x and y are both functions of t, then A is a function of functions of t. So we'll probably end up using some sort of chain rule. We take dA dt on this side, and we say the derivative of a product is the first times the derivative of the second, plus the derivative of the first times the second. But now we're in really good shape because we have all of those values that we need. For instance, we have that x at the moment we care about is 3, and we know that dy dt is minus 4. And at the moment we care about, we know that dx dt is plus 5, while y at that moment is 4. So we actually have everything we need for dA dt, and we just do some arithmetic. So we get that dA dt at that moment is 4 centimeters squared per minute. Since dA dt is positive, we have that A is increasing at the moment of interest. Using Pythagorean theorem, of course, we have that L squared is x squared plus y squared, and we need to take the derivative of that, which we'll do implicitly by saying on the left-hand side we have d dt of L squared, and on the right-hand side we have d dt of x squared plus y squared. So d dt of L squared is 2 times L times the derivative of L. d dt of this sum is, of course, the sum of the derivatives, and again becomes 2 times x dx dt plus 2 times y dy dt. We will, of course, eliminate the 2's because they're common to all factors, and we get something like dl dt is x dx dt plus y dy dt over L. And again, we have all these values, so we can say we have that x is 3 and y is 4, and dx dt is 5, whereas dy dt is minus 4, and with a base of 3 and a height of 4, the hypotenuse is clearly 5. So we end up with 15 minus 16 over 5, or minus 1/5 centimeters per minute. Since dL dt is negative, L is decreasing at this time.